In this episode, we are spending time with a model that many learners hear about early but do not always fully understand the first time through. Waterfall and the traditional system development lifecycle, SDLC, describe a structured, staged way of planning, designing, building, testing, and implementing systems so that work moves in an orderly and controlled direction. For someone new to cybersecurity and audit, this matters because many organizations still rely on this approach in some form, especially when they need clear approvals, strong documentation, predictable budgets, and visible control over system change. It can sound old-fashioned at first, but that first impression can be misleading because the model teaches some of the most important ideas in all of system governance. It shows how requirements, design decisions, testing, and implementation are supposed to connect rather than appearing as random project activities. It also helps you understand why auditors care so much about formal approvals, stage gates, and evidence that a system was built and introduced responsibly. When you understand Waterfall, you are really learning how structured system change is supposed to look when management wants discipline more than improvisation. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. The traditional SDLC is best understood as a formal path that takes a system from an initial business idea through development and into ongoing use. Instead of treating system work like one long blur of meetings, coding, and last-minute fixes, the traditional approach divides work into recognizable phases so each phase has a purpose, expected outputs, and approval before the next phase begins. The names of the phases can vary slightly from one organization to another, but the general flow is familiar: planning and requirements, design, development, testing, implementation, and then ongoing support and maintenance after the system is live. That sequence matters because it gives the organization a chance to pause and confirm that the project is still aligned with business need before more time and money are committed. It also creates a natural place for oversight, documentation, risk review, and control design. For a beginner, the most important point is that traditional SDLC is not just about building software. It is about creating a repeatable management process so that system change is guided, reviewed, and made visible to the people responsible for business outcomes. Waterfall is one of the clearest ways to picture that traditional approach because it treats the phases as a largely downward flow, where work moves from one stage into the next only after the earlier stage has been substantially completed. The image of a waterfall is useful because the model assumes that once the work has flowed into the next stage, it is difficult and costly to move back upward and make major changes. That does not mean change is impossible, but it does mean the model places heavy value on getting early decisions right, especially around requirements and design. A beginner can think of it like planning a building before construction starts. If the blueprint is clear, the budget is approved, and the purpose of each room is understood, the later work can move with less confusion. If those early decisions are vague, the same uncertainty travels forward and becomes harder to correct after development has begun. Waterfall therefore encourages disciplined front-end thinking because the model assumes that unclear beginnings produce expensive problems later in the project. One reason organizations have used Waterfall for so long is that it fits environments where predictability, documentation, and accountability matter a great deal. When a bank, hospital, government agency, insurer, or large manufacturer introduces a major system, leadership may want formal review at each stage so that cost, timing, scope, compliance, and control expectations are not drifting out of view. Waterfall supports that kind of environment because the process encourages written requirements, approved designs, scheduled testing, and managed implementation rather than constant informal change. It also works well when the business need is relatively stable and the organization already has a strong idea of what the final system should do. In those situations, the structure can feel reassuring because project leaders can estimate work, assign responsibility, and communicate progress in a way that feels orderly and easier to govern. For an audit-minded learner, this is one of the biggest reasons the model remains important. It creates an evidence trail that shows not only what the team built, but how decisions were made and who approved them at each major point. The planning and requirements phase is where the traditional model begins to prove its value, because this is the stage where the organization tries to understand exactly what problem it is solving and what the system must accomplish. Business users, project leaders, technical staff, and other stakeholders work to define scope, expected outcomes, data needs, security expectations, operational dependencies, and constraints such as time, cost, or regulatory obligations. In a waterfall setting, this phase is especially important because later stages depend heavily on the quality of what is defined here. If requirements are incomplete, contradictory, or based on assumptions that were never challenged, those weaknesses travel into design, development, and testing. That is why traditional SDLC places strong emphasis on documenting requirements clearly and obtaining formal approval before the team moves forward. It is not just administrative caution. It is an attempt to reduce ambiguity before the organization invests heavily in building something that may later disappoint users. Good requirements act like a reference point for everything that follows, and weak requirements often become the hidden cause of later project trouble. Once requirements are approved, the design phase translates those business needs into a planned solution that people can evaluate before full construction begins. Design in this context is not merely about how the screen will look. It includes architecture, data structures, system interactions, access rules, control points, processing logic, expected performance, recovery considerations, and how the system will fit into the broader technology environment. This phase matters because it allows teams to think carefully before building, which is one of the central ideas behind the traditional approach. If the system will handle sensitive information, the design should already reflect how that information will be protected. If the system must support approval workflows, data validation, logging, or separation of duties, those expectations should be visible in the design rather than added later under pressure. For beginners, the key lesson is that design is where the organization decides how the solution should work, not just what it should do. A thoughtful design reduces confusion during development and makes later testing more meaningful because the team has something stable and reviewable to build against. The development phase is where the approved design begins to turn into an actual working system, whether that means writing code, configuring software, building interfaces, or preparing data structures and workflows. In a waterfall environment, development is usually expected to follow the approved requirements and design closely, with changes managed through formal review rather than informal improvisation. This creates discipline, but it also means the earlier phases need to have been handled well, because the team is now investing effort based on what was already decided. Good development in a traditional SDLC is not just about technical skill. It also involves version control, documented work, controlled environments, peer review where appropriate, and clear distinction between development work and production operations. The organization wants to know that the system being built is the one that was approved, not a gradually shifting project driven by scattered requests or undocumented shortcuts. This phase can feel more visible than planning or design because people can now see progress in a concrete form. But the traditional model still expects that progress to remain tightly connected to what was previously defined and approved. Testing is one of the most important phases in the traditional model because it is where the organization checks whether the built system actually behaves as expected before business operations begin to depend on it. In a disciplined waterfall approach, testing is not a quick demonstration at the end. It is a structured effort to compare the developed system against requirements, design expectations, control needs, and realistic operating conditions. Teams may check whether individual functions work correctly, whether multiple components work together, whether the system handles expected volumes, and whether failures or exceptions are managed appropriately. Quality assurance, QA, activities may be especially visible here because the organization wants evidence that defects are being found, tracked, corrected, and retested in a controlled way. User acceptance testing, UAT, is also often important because business users need to confirm that the solution supports real work and not just technical assumptions. For a beginner, this phase shows why the traditional model values traceability so strongly. Testing is much more powerful when the team can point back to specific approved requirements, and show whether each one was met. Implementation is the stage where the system moves from project work into real organizational use, and this transition can be one of the most sensitive moments in the entire life cycle. A system that seemed stable in development and testing now has to interact with real users, real schedules, real workloads, and real business consequences. In a waterfall approach, implementation is usually planned carefully rather than handled casually, because the goal is to avoid introducing disruption that could have been anticipated and controlled. This phase may involve data conversion, user training, communication with affected departments, production approvals, support readiness, and fallback planning in case the rollout does not go as expected. The structured nature of traditional SDLC is very visible here because implementation is not treated as a simple technical switch. It is treated as an organized business event that must be prepared, reviewed, and governed. That matters in audit and control terms because the organization should be able to show that the system was not only built and tested, but also introduced in a way that protected operations, users, and data during the move into live service. Documentation plays a much larger role in Waterfall than many new learners first expect, and that is one of the reasons the model has remained so relevant in controlled environments. Each phase tends to produce records such as business justifications, approved requirements, design documents, test plans, defect logs, implementation plans, sign-off records, and post-implementation observations. To someone unfamiliar with formal project governance, this may look heavy or overly procedural, but the deeper purpose is accountability and continuity. Documentation helps people understand what was agreed, what changed, what was tested, what risks were identified, and who approved movement into the next stage. It also helps new team members, operations staff, auditors, and future project teams understand how the system came to exist in its current form. In other words, documentation is not just a project byproduct. It is part of the control environment surrounding system change. Traditional SDLC assumes that if important decisions are not recorded, they are hard to govern, hard to review, and hard to defend later when questions arise about whether the right process was followed. That strong documentation supports another major feature of Waterfall, which is the idea of stage gates or formal checkpoints between phases. A stage gate is a pause where management or governance bodies review the work completed so far and decide whether the project is ready to move forward. If requirements are not clear, the project should not move into full design. If design concerns remain unresolved, development should not proceed as if everything were settled. If testing reveals serious weaknesses, implementation should not be treated as a fixed calendar event that happens no matter what. This kind of structured review is one reason traditional SDLC is so attractive in environments where control matters greatly. It makes responsibility visible and prevents the project from gaining momentum so quickly that nobody feels able to stop and ask hard questions. For a CISA learner, stage gates are especially important because they create evidence of governance. They show whether the organization is managing system change deliberately or simply pushing work forward because time and money have already been invested. Waterfall also has real strengths that explain why it should not be dismissed as outdated just because newer delivery models receive more attention. The model can be very useful when requirements are stable, when the business needs a predictable delivery path, when contractual obligations require detailed documentation, or when a system change affects highly regulated or high-risk operations. It gives leadership a clearer sense of sequence, expected deliverables, and formal control points. It can also help teams that are less experienced with rapid iterative methods because the structure makes roles, approvals, and expected outputs easier to understand. In vendor situations, traditional SDLC can reduce confusion by making it clear what must be delivered at each stage and what evidence is needed before payment or acceptance. For beginners, it is worth noticing that Waterfall's strength is not speed or flexibility. Its strength is discipline, clarity of sequence, and the ability to create visible control over a project that the organization cannot afford to manage casually. At the same time, the model has limitations, and understanding those limitations is just as important as understanding its strengths. Waterfall can struggle when business needs change quickly, when users do not fully understand what they need at the start, or when early assumptions turn out to be wrong after real interaction with the system begins. Because the model expects relatively stable requirements up front, major changes introduced late can become expensive and disruptive. That does not mean Waterfall is broken. It means the model fits some kinds of work better than others. Another misconception is that because the process is formal, it automatically guarantees quality or success. It does not. A poorly governed waterfall project can still have vague requirements, weak testing, rushed implementation, or unrealistic schedules. The structure helps, but it still depends on honest communication, realistic planning, and leadership willing to stop the project when a phase has not actually met its readiness expectations. A formal sequence is valuable, but it is not a substitute for judgment, competence, or accountability. From an audit point of view, Waterfall and traditional SDLC are especially important because they create many of the records and approval points that auditors use to evaluate whether system change was managed properly. An auditor may want to see whether requirements were documented and approved, whether design decisions considered needed controls, whether development was separated from production use, whether testing was meaningful and tied back to requirements, and whether implementation had appropriate authorization and readiness review. The auditor is not simply checking whether a project followed a textbook flow. The deeper concern is whether the organization had a disciplined approach to acquisition, development, and implementation that reduced risk and supported reliable outcomes. Traditional SDLC often makes this easier to evaluate because the model is built around visible phases and documented movement between them. That is why this topic matters so much for a CISA learner. It connects project work, governance, control, evidence, and business risk in a way that is easy to observe and easier to audit than informal, undocumented development behavior. The bigger picture should be much clearer. Waterfall and the traditional SDLC describe a structured, phase-based approach to system development in which planning, requirements, design, development, testing, and implementation are handled in a deliberate sequence supported by documentation and formal approval. This matters because many organizations still need that kind of control when they are dealing with important systems, regulatory pressure, fixed contractual expectations, or environments where mistakes during implementation would have serious business consequences. The model is not perfect, and it is not the right answer for every project, but it remains one of the clearest ways to understand how disciplined system change is supposed to be governed. When you study it well, you are not just learning an older development method. You are learning why requirements matter early, why design should include controls, why testing needs traceability, and why implementation deserves careful management instead of last-minute hope. That makes this topic far more than historical background. It is one of the best ways to understand the relationship between structured development, business reliability, and audit-ready evidence.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.